5.7, graphing and solving quadratic inequalities. Let's kind of end here, chapter 5, on a good note, shall we? Quadratic inequality in two variables. It's just like graphing a regular quadratic equation. That's what we're going over now. But just remember there are solid and dashed lines because we're dealing with inequalities. If it's less than or greater than, it's a dashed line. If it's less than or equal to or greater than or equal to, it's a solid line. And also remember that you have to shade it.
Your move, creep.
So graph the quadratic. Then if it's less than or equal to, it's a dashed line. And if it's less than or equal to or greater than or equal to, it is solid, just like before when you graphed them. Then you choose a point in the parabola and check to see if it's a solution. So make sure it's inside the parabola that you choose and see if it's true. And remember, if it's true, you shade in the parabola or towards the point, and if the point is false, you shade outside the parabola or away.
Release the hounds!
So you graph that how you normally graph it. So we get our list of points here. So you plug in a -2, and when I plug in a -2, I get 5 as my answer. So I have the point -2, 5, -2, 1, 2, 3, 4, 5. Put the point there. -1, I plug the -1 in, I get 0. I plug in 0, I end up getting -3. I plug in a 1, I end up getting -4. I plug in a 2, and I end up getting -3. So let's plot the points. I get -2, 1, 2, 3, 4, 5, and I put the point. I have -1, 0, put the point there. 0, 1, 2, 3, put the point there. 1, 1, 2, 3, 4, right there. And 2, 1, 2, 3. Now I know those are all the points that are there, but you can tell the trend. You can tell that that's the bottom point and that's the vertex point, which means it's the same distance from each side. This point is down 3 and over 1, so it's over 1 and up 3 to put the next point in. From here to here, it's down 1, 2, 3, 4, 1, 2, 3, 4, 5, and over 1, so I go over 1 and up 5, and I put a point. And there is my parabola. But before I do this, it's greater than, which means it is a dotted line that goes in there. So I pick a point inside the parabola, which is 0. So I'm going to pick a point 0, 0 and plug that in. So I plug it in for all the x's and y's. So I get, is 0 greater than -3? You betcha. So that means it's true. Since it's true, that means I shade towards the point. So I shade everything inside the parabola.
Forget about it!
Example 2, and now I want to graph 2. Now once again, you just see where they overlap. So let's take a look at the first one. I plug in -2. I end up getting 0. If I plug in or I guess I'm plotting them now. So -2, 0 is right there. Plug in -1, I get -3. So the point's -1, -3. So -1, 1, 2, 3 is right there. I plot the point. Plug in 0, get -4, so that means 0, 1, 2, 3, 4. So there's 0, -4. Plot the point 1, plug in 1, so I end up getting -3 as my answer. So I have over 1 down -3. There's the point. And I plug in 2, I end up getting 0, so 2, 0. And that's enough for me to see that it's going up on each side. So since it's greater than or equal to, it's a solid line. And I'm going to plug in a point not on that line, which is 0, 0. And when I plug it in, is 0 greater than -4? You betcha, that's true. So because I have two graphs, I'm going to do like we did before when we solved systems of inequalities and we shaded. I'm going to put some arrows on the inside here, just so I remember I'm shading on the inside. So now let's do this one. Plug in -2 here. When I plug in -2, I end up getting 0. So I plug the point -2, 0 in, which is, I guess I'm going to start plugging those in at the end. Then I plug in -1. So when I plug in a -1, I end up getting 2. So I have -1, 2 as a point. When I plug in 0, I end up getting 0, 2 as a point. When I plug in 1, I end up getting 1, 0 as a point. When I plug in a 2, I end up getting 2, -4. So if I go to plot these, -2, 0 is right there. -1, 2 is right there. 0, 2 is right there. 1, 0 is right there. And 2, -1, 2, 3, 4 is right here. So there's a matching point on the other side. Now, Most people would think that, oh, I will draw this and it goes straight ahead. No. Every single time you've graphed one so far, it's been at a point. This means the point's going to be hanging out in the middle right here. It never goes straight across. So there is a point. It's just at negative a half, 2.5. That's where it's going to probably be jamming out at. There is a point right there, so keep that in mind. You don't just connect it straight across, but it also is a dashed line. Okay, so keep in mind, see how mine went up there? It's a dashed line. It doesn't go straight across there. There is a point there at the bottom of the curve. We pick a point not on that line inside the parabola, which is 0, 0. So I plug in 0, 0 there. Is 0 less than 2? That is true, meaning I shade everything in there. So where do they overlap? Inside between those two, and there is your answer.
Well, isn't that special?
A way to solve quadratic inequalities by factoring and grouping. Okay, so when we come back here, don't want to try to spread ourselves too thin here and try to race through. So when we come back here, we'll finish up and hopefully get everything done in 5.7, graphing inequalities in quadratics.